Now guys, we are going to discuss that whatever we have observed overall in this experiment, right? And are those results matching with the classical wave theory or not? Because till now we have been studying that light is a wave, right? But in this chapter we have started with the concept that light travels in the form of particle, right? If light travels in the form of particle, that means those observations should match with the classical wave as well, because neither the classical wave mechanism is wrong nor this mechanism is wrong. So we are trying to match them up. If somewhere we are not able to match them up, that means we need another concept to explain this theory. That's it. Okay, so here we will be studying the differences, what observation we are getting from that experiment and what is already mentioned in the classical wave theory. Are they matching or not? First observation. We have seen that when we increase the intensity of incident radiation, current is also increased, right? So this result matches with the classical wave theory as well. Okay. Then second observation. Current versus voltage step at 0 and then flat. So here, like we have discussed what is saturation current. Okay, so first of all we get the some non-zero current, and then we get the maximum value of current, and then we get the saturated value, right? That maximum value is saturated value. That means after that particular value there will be no increase in the current. Okay, so the classical wave theory matches that flat part only, right? The third point, color of light does not matter, only intensity. Classical wave theory says that in a light radiation, right, in a light radiation only intensity take part, doesn't matter what color are you using. But in our experiment we have seen that the frequency is the most important factor to get the electrons from that metal plate, right, out from the surface, right? Frequency is important. We have defined the term as threshold frequency. So according to classical wave theory, threshold frequency term should not be there. So there is the mismatch. We are getting the concept in terms of threshold frequency. We should satisfy that condition, then only the electrons will come out from the plate. But classical theory is not supporting that concept, because classical theory says that only the intensity should be responsible, right? But here we know that electron will come out and conduct the electricity only when whatever it needs, like in terms of frequency, that condition should be satisfied. Classical theory says that it takes time to absorb the energy, it takes time to heat up, to flow the current, right? So everything takes time. But in experiment we have seen that this photoelectric effect is the spontaneous process, right? We have discussed that it is a spontaneous process. That means radiation will fall, electron will absorb the energy, will come out and conduct the current. So there is also a mismatch.